Anyone who has punched in on the moon knows that humans haven't landed on the moon for over 50 years. In this video, I'll take you on a trip to the moon. To go to the moon, you first need a launch vehicle. This is the Saturn V rocket, which carried the lunar spacecraft. It is a 3-stage launch vehicle standing 110 meters tall. How is such a large rocket assembled? Let's start by assembling the first stage. First, workers use a transporter to move the prefabricated rocket to the assembly building. The first stage has 5 F1 engines with a total thrust of 34,000 kilonewtons. After reaching the designated position in the assembly building, workers use a crane to slowly lift the rocket and raise it vertically like this. The crane then slowly transfers the rocket to the mobile launch platform and slowly lowers it until it docks with the mobile launch platform. Next, the fixing devices at the bottom of the rocket secure it in place. Once secured, the tail service mast connects to the rocket to supply it with fuel. Immediately afterwards, the first stage's service arm connects to the rocket. Moving up to this position, a second service arm will be connected here. After these assemblies are complete, we will assemble the second stage of the rocket. Like the first stage, the second stage also has 5 engines, with a total thrust of 4,400 kilonewtons. After the workers lift the second stage, they slowly move it above the first stage. After aligning the position, the rocket slowly descends until the first and second stages are perfectly docked. Afterwards, the 3 service arms around the second stage will rotate into position one by one and connect to the interfaces on the rocket. Once these dockings are complete, the second stage assembly is finished. Next, let's assemble the third stage. The third stage has only one engine, with a thrust of only 1,000 kilonewtons. Its docking process is similar to that of the first and second stages, so we won't go into detail here. After the third stage is docked, the next thing to assemble is the lunar spacecraft. First, we need to assemble the spacecraft's lunar module, lander. The lunar module has vertical takeoff and landing capabilities, and it can carry astronauts and ultimately land on the moon. We will talk about the structure of the lunar module in detail later. After the lunar module is installed, the protective panels on the outside of the spacecraft will be installed. After precise docking, the next component to be installed is the spacecraft's service module. As you can see, the service module also has engines installed, and its main purpose is to transfer the spacecraft to the predetermined Earth-Moon trajectory. The command module is at the top of the service module, and it is also where the astronauts work and live. It is also the only module that returns to Earth during the lunar mission. Astronauts eventually return to Earth in the command module. After the lunar spacecraft is assembled, we then need to install the spacecraft onto the Saturn V rocket. Before installation, we need to install a control unit on top of the third stage of the rocket. The control unit contains a large number of electronic components that can calculate the rocket's position and speed, thereby correcting its trajectory. Once the control unit is installed, we can then directly dock the assembled lunar spacecraft onto the control unit. Then, as before, connect the 2 service arms to the interfaces of the lunar spacecraft. After the lunar spacecraft is installed, the next thing to install is the Launch Escape System, Escape Tower. The Escape Tower is installed on top of the command module, and several engines are installed at the bottom of the Escape Tower. If an emergency occurs during the initial launch phase, the Escape Tower will ignite and carry the command module to a safe area. Next, what we need to do is transfer the assembled rocket to the fixed launch pad. This tracked transporter is used to move the rocket. The transporter will drive directly under the mobile launch platform and lift it up. This moves the entire rocket out of the assembly building. Since the rocket is 110 meters tall, the entire movement process is very slow for safety reasons. The transporter is equipped with a hydraulic suspension system and an automatic leveling sensitive system. This keeps the entire platform level at all times, with the chassis shifting up and down by no more than 5 centimeters. When the transporter arrives at the designated position on the launch pad, it slowly descends, securing the mobile launch platform onto the launch pad's support structure. Afterwards, the transporter separates from the mobile launch platform and leaves the launch pad. After completing these steps, let's now look at how the lunar spacecraft flies to the moon. This is also the most exciting part of this video. Please hold your breath and watch carefully, everyone. On launch day, 3 astronauts will take an elevator to this white room and enter the command module. 30 seconds before launch, several service arms on the rocket will successfully detach from the rocket. 8 seconds before launch, the first stage engines begin to ignite. At the same time, the remaining service arms connected to the rocket all detach, quickly rotate, and separate from the rocket. With the immense thrust of the engines, the rocket can now launch. As the rocket continues to ascend, the astronauts inside the command module will experience up to 4 Gs of gravity. After 2 minutes and 40 seconds of flight, the rocket is approximately 67 kilometers above the ground. At this point, the first stage engines will shut down and separate from the second stage. Simultaneously, the second stage engines ignite, continuing to propel the rocket. The first stage will eventually fall into the sea. Since the rocket has flown high enough, the escape tower is no longer needed at this point. The escape tower will automatically ignite and separate from the rocket. At 9 minutes and 12 seconds into flight, the second stage engines will shut down. At this point, the rocket has reached an altitude of 175 kilometers above the ground. The second stage will then separate from the third stage. Immediately afterward, the third stage engine begins to ignite, then continues to propel the rocket. After 11 minutes and 39 seconds of flight, the third stage engine will shut down. At this point, the rocket enters Earth parking orbit. A parking orbit is a transitional orbit. You can simply understand it as a temporary rest stop. The rocket will orbit this path 2 to 3 times for orbital adjustments and system checks. After confirming that all systems are working correctly, the third stage engine will reignite for 6 minutes. Propelled by the engine, the rocket will leave the parking orbit and enter translunar injection. At this point, the protective panels outside the spacecraft's lunar module will open and detach from the lunar module. Immediately afterwards, the service module and command module will also detach from the lunar module. Subsequently, the service module and command module will complete a 180-degree flip. If we look at Earth from the perspective of the command module, you'll find it truly breathtakingly beautiful. Then, the lunar module side will slowly approach the command module. Through orbital calculations, the command module side will ultimately precisely dock with the lunar module. After docking, the command module will separate the lunar module from the third stage. The third stage will then crash on its own. At this point on the translunar injection trajectory, only the lunar module, service module, and command module remain flying independently. During the spacecraft's flight, because the temperature in space is extremely extreme, to prevent the components on the spacecraft from overheating or becoming too cold, the spacecraft usually flies while slowly rotating to ensure uniform heat distribution. 3 days later, as the spacecraft continues to fly, it gets closer and closer to the moon. When the spacecraft intersects with the moon, it will enter the moon's gravitational field and begin orbiting the moon. Since landing on the moon requires deceleration, the engines on the spacecraft's service module will ignite at this point to slow down the spacecraft's speed. This process will last about 6 minutes. When the spacecraft flies to the near side of the moon, we need to prepare for landing on the moon. To thoroughly understand the entire landing process, it is necessary to first understand the lunar module in detail. The lunar module is mainly divided into 2 parts, the ascent stage and the descent stage. The descent stage will eventually remain on the moon, while the ascent stage will carry the astronauts away from the moon. Let's first look at the descent stage. It has 4 legs around it. The 4 legs are initially folded for easy placement inside the lunar module. 3 of the legs have sensing probes installed at the bottom. These probes can detect if the lunar module is approaching the ground, allowing the spacecraft's engines to be shut off at the appropriate time. There is a ladder on this leg, which astronauts use to descend after landing on the moon. Next to it, there is a container where the flag can be placed. This is the internal structure of the descent stage. It looks quite complex, but it's actually just 5 box-shaped compartments. The engine is installed in the central compartment. To allow the engine to operate, oxidizer tanks are placed in the compartments on the left side of the engine, and the compartments at the front and back respectively hold fuel tanks. They are connected to the engine via pipes, ensuring its normal operation. Now, all 5 compartments are occupied, so other equipment can only be placed in these corners. For example, a lunar rover is placed here. After reaching the moon, the lunar rover will be disassembled. Astronauts can drive it on the moon. Turning to the side here, there's a large water tank, and under the water tank are lunar surface experiment devices. This device is mainly used for conducting scientific experiments on the lunar surface. Continuing to turn to this side, helium tanks are installed at this position, along with oxygen tanks and a laser rangefinder. The rangefinder has been left on the moon. It can reflect lasers back and forth from Earth to the moon for distance measurement and is still in normal use today. Finally, this position is where the MESA storage module is installed. It can deploy directly like this. There is a camera on the module pointing directly at the ladder. It can record the entire process of astronauts stepping onto the moon. Then the entire external structure is covered with a material similar to gold foil. This material is not only lightweight, but also reflects up to 97% of solar thermal radiation. Next, this is a platform. Astronauts exit the hatch and then use this platform to access the ladder. There are also 4 deflector plates at the top. When the ascent stage takes off, the thrusters will ignite and the deflector plates can protect the descent stage. Next, let's